So this is DCPPC tools and services, mastering the subprofession that is DCPPC lingo. I'm not going to talk about everything, but hopefully you'll get a good overall gist of things. Then I'll go over the utilities, the services, schema description languages, schemas, and repositories associated with this whole thing. So in general, the DCPPC is the NIH Data Commons Pilot Phase Consortium. This is kind of an initiative that we're a part of, and there's the website, Common Funds. It's often called Data Commons or DCPPC. They're used pretty much interchangeably. I would say, if you're at a conference and you ask for DCPPC and they look at you like you have two heads, say, I mean Data Commons, and then they'll know what you're talking about. Okay. Now that we know a little bit about DCPPC, I'll start talking about some of these tools involved in this. So the first tool I'm going to talk about is this BDbag, but BDbag is basically an archive containing metadata and checksums and references to the actual data files that the BDbag is supposed to represent. And there's a command line tool, a graphical user interface that goes on front of that command line tool, and in fact a API service in development for building these BDbags. And basically they have this like a file name, a checksum for the file, and a place to download that file. So they're not really doing anything particularly for you, but what they are doing is assembling all your files and associated metadata in some very smaller downloadable that people can download that, and then it basically can be used to download the full database of files. So that's what the BDbag is for. GUID or GUID, pronounced by a lot of tech people as GUID, but fallback pronunciation is GUID. No one will be confused if you say that. This is a globally unique identifier. It's not really something specific to DCPPC, but there is a DCPPC implementation of the GUID. And it's really just a unique identifier that's completely guaranteed to be unique mathematically. But the GUID that's implemented in this project is really, it's generated and closely coupled with the metadata of that object. So you cannot generate a GUID before you have metadata describing that digital object. And similarly, you cannot modify that metadata without modifying the GUID. There's another identifier, which I'll speak about next, which can be modified. Then I'm going to go into some of the services. So MiNiD is the minimal viable identifier, so not quite the GUID, but it's the MiNiD. This is a picture straight from their site, but basically what MiNiD is it's a simple service to get an identifier quickly and easily, whereas when you come with a GUID, you have to give them metadata to begin with, whereas with a MiNiD, on the other hand, you can just get a MiNiD ID to begin with, and then you can kind of get your metadata on their site and register it with that site. So you'll have a MiNiD ID that's universal, and then anyone who goes to the MiNiD site at that ID will see a page with your metadata. But this metadata, of course, can be changed. So basically, researchers can create their digital objects, store it, and share it with MiNiD, and the other people who are looking for your data can get the metadata from the MiNiD and ultimately retrieve your digital object. So BDbags and MiNiD are working together, and that's where BDbags comes in as retrieving the digital objects. But someday maybe this ID resolver that MiNiD uses, instead of this whatever identifier they're currently using, they can put in the GUID. Oh, okay, they have the white paper itself is MiNiD. So say you use like the identifier, then it has a checksum, for that identifier, the location of the file itself. So again, it's not storing anything for you other than some simple metadata. But this is pretty much as far as the metadata goes, right? It doesn't take any more metadata than this because it's the minimal viable identifier, whereas the GUID project is more, either you can use the BDbags to store your metadata and then put the BDbag on MiNiD, or someday you'll be able to use the GUID to generate an identifier that has a lot more metadata. So I figured I'd put the schema description languages kind of in the middle. So you could see a bit about how these projects are interoperating with each other. Now the description languages are a formulaic approach to ensuring that things will be interoperable. So JSON is pronounced JSON. JSON schema is basically JSON is the JavaScript object notation, and JavaScript is not Java. I just figured I'd remind people. But it's an expressive syntax, and basically it just has a key value pair, so you can have some key string, some value, but the values can be any one of object, an array, null, string, boolean, integer, right? So you can even have arbitrary nestings of objects. And basically, JSON is being used in almost every programming language, and in the past it was like XML, but now more and more people like JSON more. Basically, this JSON-schema.org came up with a way to describe what a JSON is. So we have this simple JSON here, but we can basically say that, okay, this outer part is an object of type object, and it has the following properties. It has a key string value, which has a string, type of string. We have a key null value of type null, key bool value of type boolean, and so on, right? So we can describe what this list is. This is a list of numbers, and therefore the list is type array with the items of type number. And this object, we can describe arbitrarily size JSON objects with another JSON, ironically, but this is basically what the JSON schema is about. And this JSON schema is used a lot. So that's what brings us to OpenAPI and Swagger. If you've heard this, one of the projects is dedicated to building an OpenAPI. And basically, OpenAPI and Swagger are usually used interchangeably, but there's a subtle distinction. Basically, OpenAPI is the technology, the schema itself, whereas Swagger is like the tools that use that OpenAPI schema. And the power of the OpenAPI schema, it's kind of useless if you just write it, but it's very powerful once you factor in all of these Swagger tools that are available. So basically, it's, even though I showed you JSON over here, this JSON schema, we often write it in YAML. YAML stands for YAML Ain't Markup Language, and that is a recursive acronym. That's what programmers do. But Swagger, basically, after you write this type of API definition, which I won't elaborate too much on, but basically you can say some path, there it supports a GET request, this is what it does, it wants an application JSON object, and the parameters you put in the URL are an ID of type string, what have you, and you can ultimately describe how your API functions. And the Swagger UI gives you the ability to take that written schema and actually interact with it manually. You can click these try out and then put in the values for each of this. It builds the JSON for you, makes the request and gets the response as a JSON, and validates that it is indeed the response that you said it was. So this is all cool because, once you set this API up, you can use these tools to connect with them programmatically, or even do things like API first, like you build the API first and then figure out how you're going to implement that API. Along these lines are these workflow description languages. One such description language is called WDL, WDL, pronounced WDL, and it supposedly was designed to be human readable. This is straight from their website. They say plain old scripts are low-tech and high-tech has domain-specific languages. That's the problem. Their solution, happily, is WDL. But I looked at it and this still looks kind of high-tech to me. But I think it kind of reminds me of this whole Java world where Java had Maven, which is an XML type language, and then most people have now moved to Gradle, which looks a lot like this. So it's a step in the right direction for sure in the workflow description language world. But so here's where it came from, and this is a Galaxy workflow. So if anyone's heard of Galaxy as a data science thing, mainly for biology, it's kind of a visual interface. I didn't play around with it too much, but it's an ecosystem of packages that users can, make their analysis without really having to program anything. And so you can build these workflows in this type of visual format, and ultimately scientists have made these workflows that actually work quite well, and so they want to be able to export this and use it even in another program or another workflow. So when people say Galaxy workflows, they're talking about this, and it's this very complicated XML that no one would ever write themselves. Yeah, then there's Common Workflow Language, and it's in YAML also. It kind of reminds me a lot like OpenAPI and Swagger. Basically, you can think of it as Swagger for command line tools. Because basically here you have some command line, let's say echo, and then you can specify the inputs as flags, what type they are, and such like that, all in, the standard schema.org type YAML schema. Once you've set this up, it's very commonly used with Docker containers, so that you'll have both a application that can run on any computer, but you'll also have a descriptive language telling the world how it works. What does it take as inputs? What does it give as outputs? And in particular, unlike a standard application, when you say -- help, it's all human readable. This is a predictable format that's even programmatically readable. So they have this CWL runner tool, which allows you to execute this and give it inputs. The significance of this is just like Swagger, it makes it so that programmatically we can start connecting binary applications or Docker images. So CWL, everything seems to be able to convert to CWL. So in my opinion, CWL is probably the language you'll want to write your workflow description languages in. Then we have Json-Ld. This is linked data JSON, and basically it's an extension of JSON, and it basically allows you in your JSON object to specify a schema. We've come full circle. We're using two different things. So basically in your Json-Ld, you can put this context, which is a URL to another JSON object, which defines the schema of that JSON. So then you have, for instance, this type of JSON context, and then it's pointing to this name, and that name has its own type specified somewhere else. You have the born, which is specified here. It says the type is date time. So it's kind of just a way of linking JSON to their associated types so that you have a very complicated JSON object. But it's all for good reason, because then you can kind of not only just have some JSON that cannot be understood programmatically, now it's completely checkable in terms of what type it's supposed to be and where things come from. So it's very, very flexible structure, and it's becoming the de facto for writing like universal schemas, which is what brings us to schemas. So here are some of the schemas that are being developed by this project. One schema is DATS, or the Data Tag Suite. I'm pretty sure the acronym came first, but we will see. Json-Ld schema is used for this digital object metadata. So they have this GitHub repository. It's a bunch of JSONs, and you can read the names: biological entity schema, annotation schema. So they made all these things in hopes to capture what's a good metadata for any type of object would be. And here's an example of one of these schemas. So this is a set of dimensions, and it again looks like what we've seen, these Json-Ld objects all using this JSON schema. Then we have DOS. DOS is a data object service schema for an API. So this is written in OpenAPI spec, and they have a demo server as well, so that you can request digital objects or bundles of digital objects. So if you need a digital object service, it doesn't make sense to remake the wheel. You can use this one, right? And this is the case for all of these things. If you find that you have to make a database that's storing digital objects, it probably makes sense to look at these projects and just use their schema. It was already figured out. In many cases, people have already begun building APIs that implement this schema or interact with this schema. So by using the schema, not only have they thought about things you probably might have not have thought about, but the work's done for you. Finally, we have repositories. So all these schemas, so where do they all go? Well, smartAPI is a place where people are putting their OpenAPI schemas for web-based REST APIs. It has, I guess, 45 so far. Hopefully it'll get more. You can programmatically try and connect all these APIs and send packets through them. So we're building an ever more connected and complicated web. The next thing, kind of the analog to this smartAPI, is the DockerStore, which is a repository of Docker containers, but unlike Docker Hub, all of the Docker containers have CWL and WDL specifications for them. So it's, again, nice because you can download these applications and you already know how they work because they have these workflow specification languages. And at some point, I'm sure someone will build a super app which runs all of these Docker images and routes things to all of them. So, I mean, if you think of some of our projects, for instance, we have this X2K, which takes gene lists, puts it through Kia, puts it through Chia, puts it through Gene2 networks, right? So it's a pipeline of steps. So ideally, using things like this, you can take all the different steps, the modules that have been well built, and already build these multi-stage pipelines without any extra effort.